In this video, I want to talk about parallel and perpendicular lines and how to find the equations of those types of lines. So the big thing that you need to keep in mind when we're talking about parallel and perpendicular lines is the slope of each line. And what you need to know for parallel lines is that they have the same slope. So parallel lines have the same slope. And perpendicular lines have negative reciprocal slopes. So perpendicular lines have negative reciprocal slopes. I can't spell very well. Reciprocal slopes. And all the negative reciprocal is going to be is just if you have one slope, this is going to be equal to 1 over the negative version of that slope. That's the negative reciprocal. So let's look into some examples of how we use this in algebra, okay? So let's look at some examples and how we use this in a typical algebra setting. Okay, so let's say that I had the line 5x minus 4y is equal to 8, and they give us the point 3, negative 2. So first of all, I'm going to want to find a line that is parallel to the line that I have in the question and also goes through this point. This is a very typical question that you'd be asked in any algebra test that you take for a first course, so you can expect to see something like this. This is the procedure on how to solve this problem. So for the first scenario, I'm looking at parallel lines. And keep in mind, parallel lines have the same slope. So what I'm going to do is I'm going to take the first bit and say 5x minus 4y is equal to 8. Just worry about that right now. And I want to isolate y so that I have it in the form of slope-intercepts. So I'm just going to isolate y. So I've got negative 4y is equal to negative 5x plus 8. And then I just divide by negative 4. And I have y is equal to 5 over 4x minus 2. So this is the equation of the line that we had in the question. And now we're going to find another line that goes through this point that's going to be parallel to this line. So remember, for parallel, the slopes are the same. So m1 is going to equal m2. So we know we're going to use this number, 5 over 4, for the slope here. And we also have a point. So when we have a slope and a point, we can put it in point-slope form and then solve for the second line. So remember, point-slope form, I've got y minus negative 2 is equal to 5 over 4 times x minus 3. Okay, and then all you got to do is simplify and isolate y. So I have y plus 2 is equal to 5 over 4x minus 15 over 4. And then I subtract the 2 from either side to isolate y. So I have y is equal to 5 over 4x. And you're going to subtract another 2. So this is minus 23 over 4. And this is going to be our answer. So this is the equation of the line that's parallel to our original line and goes through the point 3, negative 2. And notice how the slopes here are the same, but they do have different y-intercepts. So if you graph these, they're going to be parallel to each other on the xy plane. And now for the second scenario, this tends to trip people up, but the only thing that we're really changing is the slope. That's the only difference between the procedure whenever we solve for parallel lines and perpendicular lines. So from the first part of the question, I already know what the equation is of our original line in the form that we want, so I can just use that. I'm just going to plot it down. So I have y is equal to 5 over 4's x minus 2. And we know what point we're going to go through. However, the only thing that we're going to change is the slope. So my next procedure, my next step in the procedure is to use the point-slope form. So I'll have y minus negative 2 again is equal to the negative reciprocal slope. So this is going to be negative 4 over 5 times x minus 3. The only thing we're changing in the procedure is the slope. And all you got to do is flip the fraction and then add a negative sign. That's the negative reciprocal. And then we solve for y again, just like we did in the last part. So we got y plus 2 is equal to negative 4 over 5x, 4/5 x, plus 12 over 5. And then when I subtract a 2 from either side, I've got y is equal to negative 4/5 x minus 4 over 5. And this is the equation of the line that's perpendicular to our original line and goes through the point 3, negative 2. All right, in the next example, I've got 2x plus 3y is equal to 5, and it's going to go through the point negative 8, 3. So for our first part in the procedure, I like to find the parallel lines first. So the first step is to take our original line and solve it into y-intercept form. So I'm going to have 3y is equal to negative 2x plus 5, and then when I divide by 3, I get y is equal to negative 2/3 x plus 5 over 3. Okay, so this is the equation of our original line that we're going to be referencing, and then I know that parallel lines have the same slope, so I'm just going to use the slope negative 2 over 3 when I apply the point slope form. So I've got y minus 3 is equal to negative 2 over 3 times x minus a negative 8. So be careful with those negatives. So whenever I distribute, I've got y minus 3 is equal to negative 2/3 x plus, well, I got a negative, cancels each other, and then this is a negative 2/3, so it's still minus 16 over 3. And then the last step is just to add 3 to both sides. So I'll have y is equal to negative 2/3 x minus 7 over 3. So this is the equation of the line that goes through this point and is parallel to our original line. So notice how the slopes are the same again, because that's what we do for parallel lines. And then number 2 is the perpendicular case. So I still have my original line and slope-intercept form that I'm going to reference. So I've got y is equal to negative 2/3 x plus 5 over 3. And then I'm going to use point slope again, but again, I'm going to have to flip the slope and take away the negative sign to accommodate the negative reciprocal condition for perpendicular lines. So I'm going to have y minus 3 is equal to 3 over 2 x plus 8, since we know the negatives are going to cancel out from the last example. So I just got to distribute, so I got y minus 3 is equal to 3/2 x plus 24 over 2, which is just 12. And then the last thing, I just had to add 3 on both sides. I have y is equal to 3 over 2x plus 15. Plus 15. And this is the equation of the line that's perpendicular to our original line and goes through the point negative 8, 3. So I hope this lesson about parallel and perpendicular lines was helpful to you. This is something that tends to trip people up, but it really doesn't have to be that way. So I hope you guys enjoyed, found some value out of it. I'll see you guys for the next video. Take care, everybody.